In this module, we're going to learn about dimensional analysis. What is dimensional analysis? It's a very useful tool for solving a large number of the word problems you encounter in chemistry. And as the name implies, it works by setting up an equation and ensuring that the units or the dimensions cancel out algebraically. All right, so there's basically 3 steps to this technique. And so you're going to be reading a word problem, and as you're reading that word problem, you're going to ask yourself these questions and answer them. Okay. One of the first question is, what units will your answer be in? So as you're reading that word problem, they're going to, most of the time, somewhere in there, tell you what units your answer will have. Notice there's no number associated with this. It won't be until you finish solving the problem. But the starting point, that's what I call the thing that you're going to start with, right? The starting point. In other words, almost all the time with these word problems that you can use dimensional analysis for, what you're being asked to do is convert a number with units to a different number with different units. The starting point will have a number, a magnitude associated with it, as well as the units. Whereas your answer, okay, you have to figure out what the number is. They tell you what the units are. And the third thing you're going to be looking for are conversion factors. Now this at first, sometimes people have a little problem figuring out, but you get used to it and you figure it out eventually. So the conversion factors are relationships between 2 different units. For example, we don't need it for this one necessarily, but 1 foot is equal to 12 inches. That's a conversion factor. That relates feet and inches. It says 1 foot is equal to 12 inches. And what we're going to do, I'm going to ask you to do, is always write these as equalities, not as a ratio. I mean, you could say there's 1 foot per 12 inches. But there's a reason that I'm going to ask you to not do that, but rather write it as an equality like this. All right, so now what we can do, okay, these are the 3 steps. Make sure you know what they are. Those conversion factors, where do they come from? Sometimes they're in the problem themselves. Sometimes they're relationships that you're expected to know. One source of conversion factors that you already know are the prefixes in the SI system. For example, you know that 1 picometer is equal to 1 times 10 to the minus 12th meters. How do you know that? Well, you know that the prefix pico means times 10 to the minus 12th, and all we do is we take that prefix and we replace it with what it means, keeping everything else there, the 1 and the m. That's a conversion factor that says that 1 picometer is equal to 1 times 10 to the minus 12 meters. So where else? Well, this table right here, this is a table, I'm asking you to memorize. 1 meter is equal to 1.094 yards, for example, and the rest of these. If it's exact, I tell you that it's exact. If I don't say it's exact in here, then it's not. So in this first one, 1 meter is equal to 1.094 yards. There's 4 significant figures. The 1.094 has 4 sig figs. Now the 1, that's exact, right? The 1 here is exact. The 1 here is exact. But the 453.6 grams is equal to 1 pound. 453.6 is 4 significant figures. The 1.06 has 3 sig figs, and so on. All right. So make sure you memorize these. It'll be real useful. This one in particular, 1 cubic centimeter is equal to a milliliter, we use quite often. All right, so memorize those. Now let's do an example. So let's say we wanted to know, okay, there's an engine, 6.5 liters. If you're, I guess it's old school now, you think about cubic inches instead of liters. So how many cubic inches is a 6.5 liter engine? Well, let's walk through our steps. First step, what units will our answer be in? Well, cubic inches, right? Because that's what we want to find, is how many cubic inches. That's our unit. We want to find the number that goes in front of cubic inches, right? What's our starting point? What do we want to convert into cubic inches? Number 6.5 in units, liter. See how that works? That's the first 2. All we need now are conversion factors. So let's look at some of those. All right, so step 1, how many cubic inches? I put a blank there. We're going to fill in the blank. When we get that number that goes here, we're done. Second step, starting point. It goes on the other side of the equal sign. So I put the units of my answer equals my starting point, number and units. All right, so now we have to convert liters into cubic inches. This is sometimes a sticking point for people. But what you do is you start with, look at your starting point. A lot of times, it really works well to say, okay, what do I know about liters? Well, I know a liter is 1,000 milliliters, and that's exact. Or I could say 1 milliliter is equal to 1 times 10 to the minus 3 liters. That's exactly the same thing. That converts liters to milliliters. Well, we're not there yet, that's for sure. But I do know, remember that one? 1 milliliter is equal to 1 centimeter cubed, which is also exact. And, okay, and we're getting there, but we still need cubic inches, not cubic centimeters. What we do know a relationship between inches and centimeters. 1 inch is equal to 2.54 centimeters, exactly. It's not cubic, but here's what you do. If you know this relationship, you guys see that if we knew the relationship between cubic centimeters and cubic inches, then we would have an unbroken path. We could convert liters to milliliters, milliliters to cubic centimeters, and then if this were cubed, we can convert cubic centimeters to cubic inches, and we do it. All right, so this is not the relationship though, but it's close. Here's what we do. If we know a relationship that looks like 1 inch is equal to 2.5 centimeters, to get the cubes, all we do is cube both sides. Thing to be careful about is make sure you cube both the number and the units. So when we cube 1 inch, 1 cubed is 1. That doesn't change. Now we have inches cubed. 2.54 cubed ends up 16.387064, and now the centimeters are cubed. The reason I kept all these numbers here is because it's still exact, right? Remember, 1 inch is exactly equal to 2.54 centimeters. That gives us everything we need. We have an unbroken path. So now all we do is set it up, right? So we want to know how many cubic, that's supposed to be inches. Pardon me for a second. Is equal to 6.5 liters. Looking at our conversion factors, so here's where it's the dimensional analysis. Okay, we're algebraically making the units cancel. So liters here, okay, and this is also why I ask you guys to write conversion factors as equalities, because that helps you figure out which goes in the denominator, which goes in the numerator. So because liters is in the numerator, we need liters in the denominator. That puts the 1,000 milliliters in the numerator. Liters cancel. And I encourage you to physically cross out the units just like this, because that's where you catch yourself if you have something upside down. Now, you need to cancel out milliliters, because that's what we have at this point. Well, 1 cubic centimeter is equal to 1 milliliter, so the milliliters cancel. We're at cubic centimeters, and we just figured out the relationship between cubic centimeters and cubic inches. We set it up like this, with this on the bottom, the cubic centimeters cancel. The units that we have left, that's what we're trying to find. Plug all these into your calculator, and the 6.5, that's a measured number. That's not exact. That is 2 sig figs. This is exact, so basically an infinite number of sig figs. Exact and exact. The 6.5 limits us. We have 2 sig figs. And you put this in your calculator, and please make sure you do this and make sure you get the same numbers as I do. So I got 396.6 and then a bunch of other numbers, inches cubed. So I always write first 1 or 2 insignificant figures as subscripts. Remember, 2 sig figs, 1, 2. When I round, okay, my first number that I'm dropping is 5 or bigger, so I round up. 9 becomes a 10, 3 becomes a 4. And I get 400, not 40, notice, okay, but 400. However, the problem is, if I wrote 400, just like that, how many inches cubed? How many sig figs? 1, right? Because there's no written decimal point. If I put the decimal point, now how many sig figs? 3, right? 1, 2, 3. but I only need 2. The only way to write this number to 2 sig figs correctly, that we're using anyway, is to use scientific notation. So this is not right. Get rid of that. The right answer is 400, or 4 into 2 sig figs is 4.0 times 10 to the second cubic inches. So 6.5 liters is about 400 cubic inches.